All right. What's the domain of K? Huh? Don't mumble at me.
I said my name.
Oh, did you? I'm glad you know that. But what's the domain of K? Oh, stop it. Huh?
Is it just?
Yeah, because there's no division and there's no square root or fourth root or sixth root or anything like that. So the domain of K is negative infinity to infinity. All right, that's something you're going to have to be able to do. So let's move on to the following. The algebra of functions. So, the sum if I want to do f plus g of x, let's say I have some f of x and some g of x, and I want to do f plus g of x, what do you suppose you would have to do? Yeah, take f and take g and add them together. So literally this is f of x plus g of x. Well, guess what that is? Minus g, yeah. So what do you do for that one? No. Product is multiply, right? So this would be f of x times g of x. All right, you want to answer that one? Yes, clearly it's multiply. There's only one small problem with this one. Anybody think of what it might be? Hey, you got to be careful of division by 0. So on this one, you have the added stipulation that g of x cannot be 0, because if it were, then you'd have division by 0, which is extremely bad. Now, all of this should seem pretty intuitive. The only thing that kids tend to struggle with is when you have to find the domain of these things. So the domain of these, I guess I should say domains. I think that's grammatically correct now. are the domain of F intersected with the domain of G. With the obvious exception of the quotient, where you also have to worry about G not being 0. Just think about it this way. Let's say that this thing is the domain of F. So these are all the x's where F is defined. And let's say that this, somewhere here, is the domain of G. So those are all the x's where G is defined. Well, if I want to do something like F plus G of x, wouldn't it stand to reason that if this is going to make any sense, F would need to be defined and G would need to be defined? Because if either of those is bad, then the whole thing is going to be bad. So the domain would have to be this part in here, where both of the functions that you're adding together have a valid output, that they make sense. Like, for instance, if I were adding together, if we go backward, if I were adding this function, this h, to this a, I couldn't have positive or negative 7 in a. I couldn't have anything less than negative 4 of h. So the domain would be this guy, except 7 would be removed because a wouldn't make any sense at 7. So you're taking the overlap between the two. They both have to be defined. I don't know if that made any sense or if that clouded the issue. All right, let's do some examples to make sure we've got it. So let's say that f of x is equal to 2x minus 1, and g of x is equal to x squared plus x minus 2. First of all, what's the domain of f? That should not have been a hard question. Yeah, it's all real numbers. There's no division, there's no square root, so I mean, there's no problem. So what's the domain of G? Same thing. So that means when I do like f plus g and f minus g, the domain, since this is defined everywhere and this is defined everywhere, the domain of f plus g would also be negative infinity to positive infinity. So let's figure out what f plus g is. What is f plus g? And you get that by just adding those together and combining like terms. You probably don't need to show a whole ton of work for that. This one, on the other hand, might be at least a little bit of a good idea to show a little bit of work. How would you go about this one? So if I were to write it out, it would be 2x minus 1 minus x squared plus x minus 2. And then you can switch the signs and then add it together, right? So you would end up with what in this case? Negative x squared plus x plus 1. I concur. So how about f times g? How would I have to do that? Yeah, basically I would have to FOIL it out. Distribute, yes. This is what, 2x minus 1, x squared plus x minus 2. So if we FOIL that real quick, this is what, 2x cubed plus 2x squared minus 4x minus x squared minus x plus 2. And that would come out to be 2x cubed plus x squared minus 5x plus 2. And we discussed what the domains of these would be, right? All real numbers. So let's compute f over g of x. What would that look like? Don't think too hard. What's the domain of that one? Is it all real numbers? Not necessarily, because what do you have to worry about? Division by 0. So what would probably be the easiest way to figure out where division by 0 occurs? Yeah, factor the denominator. Basically, think about setting it equal to 0. What does the denominator factor into? So I would have to avoid what? Negative 2 and positive 1? So the domain of f over g would be negative infinity to negative 2, union negative 2 to 1, union 1 to infinity.